Hello students, we have seen angle between radius vector and the tangent. Angle between radius vector and tangent was what? Tan theta is equal to or tan phi is equal to r d theta dr. Okay. So, this was the angle between radius vector and the tangent to a polar curve. Today we will see angle between two polar curves, angle between two polar curves. Suppose two polar curves are given, how to find the angle between two polar curves. Okay. So, from this concept, questions are generally asked in the exam, how to find the angle between two polar curves. Now, let us see the concept first, how to do this thing. Suppose two polar curves is given, one curve is r equal to f1, f1 theta you can take, another curve you can take r equal to f2 theta. Suppose this curve and another curve I am taking like this. Okay. One curve is denoted with r equal to f1 theta, another curve is given as this above, this curve is given as suppose r equal to f2 theta. So, two polar curves we are taking which are intersecting at the point P. Suppose this is the point P. Now, we have to find the angle between these polar curves, means at the point of intersection we have to find the angle between these two polar curves. Now, see these two curves, these are curved surface or curved line. When two curved lines intersect, we cannot find the angle between them. So, what we need to do basically, we need to draw the tangent at this point P. Okay, so, two different tangents I will get. Suppose this is one tangent and this is another tangent, suppose I am getting. Now, see if I am able to find the angle between this tangent, then I will say this is the angle between the tangent as well as this is the angle between the two polar curves. So, you have to basically find the angle between the tangent at the point of intersection, because tangent can be drawn at a particular point only. So, suppose this one again I am taking this axis. Okay. So, this tangent, one tangent, suppose this is intersecting x axis at t1 point, another tangent suppose it is intersecting x axis at t2 point. This is your origin and this is your suppose y axis. Okay. I am joining this O point and P point. Okay. This is your radius vector r. You know this thing. This one will come as theta, the polar angle theta. Okay. This is the polar angle theta. So, this figure basically I have drawn in the last when I have shown the angle between the radius vector and the tangent to a polar curve. So, then what we need to do? We have to find the angle between the tangent. Now, how to find the angle between the tangent? Directly you see we cannot find. So, angle between radius vector and the tangent we know the formula tan phi is equal to r d theta dr. Okay. So, what we will do? First we will find the angle between the radius vector and the tangent PT1. Suppose this angle is phi 1, I am taking this angle is phi 1. Another I will find another angle, that is angle between the radius vector and the tangent PT2. Suppose this one is phi 2. So, now if I find phi 1 minus phi 2, phi 1 minus phi 2, you see phi 1 angle, if I subtract phi 2 angle from this phi 1 angle, we will get the required angle between the two tangents. So, this will be your angle between two polar curves, angle between the tangent at a particular point, that means this will give you the angle between the two polar curves phi 1 minus phi 2. Okay. So, this is your angle between two polar curves. Okay. Now, how the problem comes, I will show the problem. Sometimes what happens, sometimes two polar curves, suppose two polar curves are given in the exam. So, we have to basically find phi 1 and phi 2. From the first polar curve, we have to find the expression of phi 1, and from the second polar curve, we have to find the expression of phi 2. So, if phi 1 and phi 2 we can find by using that same theorem, tan phi is equal to r d theta dr, or you can use cot phi is equal to 1 by r dr d theta. We have to find phi 1 and phi 2 and we have to subtract this. Then we can easily find the angle between two polar curves. Okay. Now, what happens sometimes one problem happens here. Suppose phi 1 and phi 2 we cannot find explicitly in terms of suppose a particular angle we cannot find as phi 1 and phi 2. In that case, we have to apply tan formula. This one can be used by tan formula, tan of mod phi 1 minus phi 2. This formula we have to apply. Now tan of mod phi 1 minus phi 2 can be written as mod can go outside tan. So in first bracket we will write phi 1 minus phi 2. Okay. When the case when we cannot find explicitly the phi 1 and phi 2 angle. So mod of tan A minus B. So we can write this one as mod tan A minus B formula tan A minus tan B divided by 1 plus tan A into tan B. We can apply this formula when phi 1, phi 2 we cannot find explicitly. Now at the last we can find phi 1, phi 2, phi 1 minus phi 2 because we need basically this one phi 1 minus phi 2. That will be equal to tan inverse. This entire thing whatever we found, this entire thing will come tan inverse mod of tan phi 1 minus tan phi 2, okay, divided by 1 plus tan phi 1 into tan phi 2, because ultimately the answer should come as mod of phi 1 minus phi 2. Tan inverse mod of tan phi 1 minus tan phi 2, 1 plus tan phi 1 into tan phi 2. With the help of this formula, first we will find phi 1 and phi 2. If explicitly we are getting the angle, then no problem, mod of phi 1 minus phi 2 directly we can do. If we are not getting the angle explicitly, then we have to apply tan formula. So here with one example I am showing this thing. Now with one example I am showing, suppose one question is given, find the angle between the polar curves, find the angle between the polar curves r equal to a into 1 minus cos theta, a into 1 minus cos theta, and another curve is given r is equal to 2a cos theta. Okay. R equal to a into 1 minus cos theta and r equal to 2a cos theta. So you see two different polar curves are given which are function of theta, r is function of theta. So you have to find the angle between these two polar curves. How to find the angle between these two polar curves? So what we need to find? We have to find the angle between radius vector and the tangent at the point of intersection, and here also we have to find the angle between the radius vector and the tangent at the point of intersections, because suppose these two polar curves are intersecting at this point, at a particular point, suppose these two curves are intersecting, suppose P point. So we can draw the tangent at the P point. So two tangents we will get, we will separately find the angle between radius vector and one tangent and then angle between radius vector and another tangent. Now let me check how to find this thing. So first curve I am taking r equal to a into 1 minus cos theta, r equal to a into 1 minus cos theta. So this type of problems two ways can be done. You can first find dr d theta and then you can find d theta dr and multiplied by r you can find tan phi, then you can go to cot phi. Otherwise, one easy technique is first you take log on both sides, okay, taking log on both side, taking log on both side, what we will get? First let me check. So this side I will get log of r is equal to log of a into 1 minus cos theta. So first let me write a into 1 minus cos theta, okay, log of a into 1 minus cos theta. So once again I am writing log of r is equal to log of a into b, that means we can break it as log a plus log of a 1 minus cos theta. Okay, students be careful here, log of ab we can write log a plus log b, okay, log of a by b we can write log a minus log b. So first we have separated these terms as log r is equal to log a plus log of 1 minus cos theta. Now what we need to do, we have to differentiate both the sides with respect to the independent variable theta. So here I am writing differentiating both sides with respect to theta. Always whenever this type of question comes, you remember that we have to differentiate with respect to the independent variable theta. Independent variable means r is a function of theta, so the independent variable is coming as theta. Okay? So, we have to differentiate always with respect to this theta. So, if I differentiate log r with respect to theta, what I will get? So, next line it will come 1 by r, not only 1 by r because r is a dependent variable of theta. So, 1 by r into dr d theta, this thing will come. Now, left hand side will be only this much term 1 by r dr d theta. Right hand side log a differentiation will become 0. Log a is a constant term. So, this will become 0. Now, log of 1 minus cos theta. So, 1 by 1 minus cos theta, and cos theta differentiation is minus sin theta, but here 1 minus is present. So, it will come into sin theta. You have to differentiate this 1 minus cos theta term also with respect to theta. So, 1 by 1 minus cos theta into sin theta it will come. Now, left hand side you see 1 by r dr d theta. This can be written from the theorem, from the formula. This is actually cot of phi. Tan phi is equal to what? Tan phi is equal to r d theta dr. So, cot phi will come 1 by r dr d theta. So, we can write directly cot phi. Now, since this is the first graph we are doing, 2 times we have to find cot phi angle. So, better you can give name phi 1. This is just one notation. Second angle for the second curve we will write as phi 2. So, cot phi 1 will become what? Cot phi 1 will become sin theta divided by 1 minus cos theta. Now, we have to make this right hand side expression. You see right hand side one expression is coming in terms of sin and cos, but ultimately we have to make the expression in terms of cot, then only we can equate the angle. So, first we have to think how we can make this cot. Okay. So, here what we can do, sin theta 1 by 1 minus cos theta is given. So, we can break it in the trigonometric formula 2 sin theta by 2 into cos theta by 2. This is sin theta formula, and 1 minus cos theta. 1 minus cos theta is what? 2 sin square theta by 2. 1 minus cos theta, 2 sin square theta by 2. So, ultimately we will get 1 sin theta will get cancelled, 2 will get cancelled, cos theta by 2 by sin theta by 2. So, ultimately we will get cot of theta by 2. So, you see left hand side is cot phi 1, right hand side we are getting cot theta by 2. It should be positive. If it is coming something negative sign, then we cannot equate. So, from here we can get the angle phi 1 is equal to theta by 2. So, this is my first angle. First angle came explicitly in terms of theta, theta by 2 it came. Okay. So, left hand side cot phi 1, right hand side cot theta by 2, we can equate the angle, we are getting phi 1 as theta by 2. Now, come to the second curve. From the second curve also we have to find the angle. So, second curve was what? Second curve was r equal to 2a cos theta, r equal to 2a cos theta. Same way here also we will take log, taking log on both sides, taking log on both sides. So, if I take log here, taking log on both sides, what I will get? I will get left hand side as log of r, right hand side again you can break in two parts, we can take log ab. So, constant term you can write first log 2a. You can break it as log 2 plus log a plus log cos theta, or 2a also you can take directly log 2a plus log of cos theta, log 2a plus log of cos theta. So, this term will come. Students, first you take the log correctly. Okay? If the log taking this part, if you are doing wrong something, then mistake will happen, angle will not come properly. Okay? So, log r is equal to log 2a plus log of cos theta. Again we will differentiating with respect to theta, the independent variable theta. So, left hand side it was log r. So, we will get same type of expression 1 by r dr d theta. So, that is why I will always recommend do this problem by taking log, because if you take log and then differentiate with respect to theta, left hand side directly this expression will come 1 by r dr d theta, you can write cot phi. Otherwise, if you take without log, if you do, then separately you have to differentiate dr d theta, then again you have to multiply with 1 by r expressions. Okay. So, better directly with log you can do. Right hand side log 2a differentiation with respect to theta will come 0, and log of cos theta differentiation is 1 by cos theta. Now, cos theta differentiation is minus of sin theta, okay, minus of sin theta. So, what I will get, this one I can write cot phi, but here I told that we can give the name to the angle. First angle we have given name phi 1. So, here just I am giving phi 2. This is only notations phi 1, phi 2. So, this one will come minus of sin theta by cos theta. So, that means minus of tan theta. This is coming minus of tan theta. Now, see here, left hand side is cot, right hand side is coming tan, that too with a negative sign. So, we cannot compare the angle, we cannot equate both the sides. Phi 2 we cannot write as minus theta something, we have to bring something with positive cot, then only we can compare. So, if other than cot any other thing is coming, we will first try how we can represent this in terms of cot. Now, you see here minus tan is present, minus tan theta. From this minus tan theta, we have to bring positive cot something, then only we can compare. So, what is the technique here? From here, we have to write cot of something. Now, how to write? So, remember students, when from tan to cot we are going, or suppose sin to cos we are going, or vice versa, cos to sin or cot to tan we are going. So, we have to take odd multiple of pi by 2. So, 1 into pi by 2, odd multiple means here I am taking 1 into pi by 2. Here this same angle theta will come. The technique I am telling in easy way, I am trying to tell, 1 into pi by 2, here theta will come. This same angle, if suppose here 2 theta is present, here also 2 theta will come, here 4 theta is present, here 4 theta will come. So, first I will check I am going tan to cot or cot to tan, or suppose sin to cos or cos to sin. If I am changing these trigonometric expressions, so here 1 into pi by 2 will come, then here theta I will put. Now, the thing is in between there should be positive sign or negative sign, that thing you have to understand correctly. So, how to understand? Here you see this is given minus tan. Now, I hope all of you know all sin tan cos rule. This is all, this is sin, this is tan, this is cos. Means in this quadrant, suppose this is the first quadrant I am taking, first, second, third, fourth. First quadrant all the trigonometric values are positive, second quadrant sin is positive, third quadrant tan and fourth quadrant cos. Now, minus tan theta means whatever this angle is coming with a negative sign it is coming. That means pi by 2 plus theta if I do, this is your 0 line. This is theta equal to pi by 2 line. Okay, remember this thing. This is theta equal to pi line. Okay. So, like that it continues, one complete circle it will continue, okay, in this direction it moves, ultimately it will come to theta equal to 2 pi, okay. Theta equal to 2 pi means 360 degree. So, theta equal to 0 line, theta equal to pi by 2 means 90 degree, theta equal to pi line. So, if I do pi by 2 minus theta, suppose I am putting pi by 2 minus theta, then what will happen? Then the angle will come somewhere in the first quadrant, suppose like this it will come. If I am doing pi by 2 minus theta, means from this 90 degree I am subtracting this theta, so angle will come somewhere here. So, but here tan is positive, it will not give the correct result, here tan should be negative. So, if I bring the angle in the first quadrant, then what will happen? In that case tan will become positive. Okay. So, we have to make in which quadrant? Pi by 2 plus theta. If I do pi by 2 plus theta, the angle will come somewhere in the second quadrant. So, if the angle comes somewhere in the second quadrant, so tan negative will come here. So, I will get cot of pi by 2 plus theta. Okay. So, two things you have to remember. The easiest way is first you check from tan to cot I am going or minus cot to cot I am going. Suppose here it can come in other problem minus cot theta. So minus cot theta means cot to cot if I am going, minus cot to positive cot, if the same trigonometric function I am keeping, suppose cot to cot I am going, then this one should be 2 into pi by 2, even multiple of pi by 2. Then here same angle, and after that you have to check whether the sign is positive or negative. If negative sign is there, then you check which quadrant we have to bring it. So cot of pi by 2 plus theta here I am getting. So now I can easily equate phi 2 is equal to pi by 2 plus theta. So I will get phi 2 is equal to pi by 2 plus theta. Okay. This is I am getting from the second curve. This is second angle. So first angle I got theta, second angle I got first angle I got theta by 2, second angle I got pi by 2 plus theta. So now we can easily find, just only one step is remaining, angle. So angle between polar curves will be what? Angle between the polar curves will be, we will just subtract the value of phi 1 phi 2, okay, but give with a modulus sign because we do not know which angle will be greater. So mod of phi 1 minus phi 2. So phi 1 we got theta by 2 minus this one I got phi 2 as pi by 2 plus theta. Students, always use bracket here, okay, because inside mod you are calculating. So this is 2, okay. So now theta by 2 minus pi by 2 minus theta, okay. Then remove this bracket first, keep the mod outside as it is. So this one will be theta by 2 minus theta, so minus theta by 2 minus pi by 2. So now how to remove the mod? Take the negative sign common. So this will be theta by 2 plus pi by 2, give bracket, then mod sign. Now if I want to remove the mod, what will come? It will come theta by 2 plus pi by 2. So this will be your answer for this, theta by 2 plus pi by 2. Now one thing you have to note down, if you stop here, then 1 or 2 mark may be deducted in the exam, because your final answer, the angle between the two polar curves, so angle must be a constant, the answer should be a constant, because two polar curves, they are intersecting at this particular point. The final answer should not contain any variable. Variable is which one? Pi by 2 is 90 degree, a constant. But here you see this theta term is present. Final answer should not contain any variable. Suppose I am getting the final answer as only pi by 2 or pi by 4, then okay, in that point you can stop, you will get the full marks, because that is a constant angle. But suppose something theta term is present, then you have to find the particular value of theta at this point of intersection. So how to find? Just one small step you have to do here. You will write at the point of intersection, at the point of intersection means at the point P. That also you can write, if you are showing the figure, at the point of intersection we will equate both the R. So R equal to F1 theta, R equal to F2 theta. So F1 theta equal to F2 theta we can find, because angle of intersection means at that point P point is common to both the curve. So what we will write? A into 1 minus cos theta is equal to 2a cos theta. In the problem, whatever the two curves are given, we will just equate both the sides. A into both the R we will equate. A into 1 minus cos theta is equal to 2a cos theta. Means at this point is common to both the curve, this P point. Means this will satisfy both the equations. So from here we can find the particular value of theta. So A will get cancelled, 1 minus cos theta is equal to 2 cos theta. So from here if I add this one, so I will get 3 cos theta is equal to 1. So that means we will get cos theta is equal to 1 by 3, and that means theta is equal to cos inverse 1 by 3. You see, one particular value of theta we are getting. This is a constant number, okay. So no need to find the value in calculator, just you keep in this form, cos inverse 1 by 3 means at this point the value of theta is cos inverse 1 by 3. So now again you write the final answer, angle between the polar curves. In the expression you just put the theta value, angle between the polar curves. What we got the angle? Theta by 2 plus pi by 2. This one we got angle between the polar curves. So now in place of theta you just put this expression, this value of theta. So, this will be equal to half, then cos inverse 1 by 3 plus pi by 2. So, this will give you the final value of this angle. Okay. So, here you see this is a constant number. Okay. If you can find in the calculator, you can find also, you see this is a constant number. So, final answer must be a constant. We should not keep this type of form, theta form we should not keep. So, whenever this problem comes, first you find phi 1, then you find phi 2, you find the angle correctly phi 1 and phi 2, then subtract phi 1 minus phi 2, you see final answer. If final answer is coming suppose pi by 2 or only pi or suppose pi by 4, this type of result is coming, then no problem, you can stop. But the final answer, if it is coming in terms of theta, if you see that theta is present, then you have to find the particular value of theta at the point of intersection. So, how to find? At the point of intersections, whatever our expressions are given, we will equate, and we can easily find the expression for theta at the point of intersection. This value of theta is at the point of intersection only. Then you just replace the value of theta, you will get the final answer. Okay. So, this type of questions you should practice. Okay. Thank you, students.